In this video, we'll be going over spoke tension, why it's important, how to measure it, and also how to adjust. Spoke tension is the amount of pulling force being exerted along a spoke. It is typically measured and called out by component companies in kilograms of force or in newtons. When truing or dishing a wheel, the mechanic is making adjustments that affect spoke tension. Good wheel tension is not just about an individual spoke though. It's about the consistency of all the spokes coming together and creating a nice rigid structure. So why is spoke tension important? Well, without it, things would tend to fall apart. When you're out for a ride, your wheel flattens slightly where it meets the ground. As this happens, the spokes at the bottom of the wheel lose some tension. This cycle of gaining and losing tension happens throughout the entirety of your ride. If a wheel's tension is too low, it can cause the spokes to relax too much during a ride, creating a snapping effect and causing excess stress to both the spokes and the rim. This can lead to detensioning, which is when spokes lose tension over a short amount of time. This leads to breaking spokes, rim fatigue, and a not so durable wheel that will go out of true more often. At the other extreme, too high of spoke tension can cause cracks in the rims, broken spokes, or even damaged hubs. Before we get to measuring tension, we should really figure out what our tension should be. Consulting with your rim manufacturer's website is a great place to start. Most rims have suggested ranges from about 100 to 120 kgf. This is assuming there is no pressure in the tire. As for measuring spoke tension, one method is to squeeze the spokes. Though not foolproof, squeezing spokes from a wheel you know to have good tension is a way to get a sense of what acceptable tension is. Squeezing is a more accurate way of measuring spoke tension than, say, perceived effort when turning a spoke nipple. Like any fastener, the nipple will tend to become more difficult to turn as tension increases. But this doesn't always mean that the tension is too high. It could have corrosion or just be at the end of the threads. The best way to measure spoke tension is with a spoke tension meter, like the Park Tool TM1. Spoke tension meters flex a spoke between two posts with a calibrated spring. This deflection is shown on the meter's scale. To accurately use the Park Tool TM1, you're going to need to know the diameter of the spoke and also the material of the spoke. This spoke is a round steel spoke. The diameter in the middle of the spoke is 1.8 millimeters. When using the TM1, make sure to place the two fixed posts on the narrowest parts of the spoke, or in the middle of the spoke. This steel spoke is giving us a reading of 15. Looking at the TM1 chart, we find the steel round spoke section and scroll over to our spoke's diameter, 1.8 millimeters. With our TM1 reading of 15, that places the tension of our steel round spoke right at 58 kgf. This rim's manufacturer calls out a max tension of 110 kgf. We are going to set a tension goal for this wheel of 100 kgf on average, which for our spokes is a reading between 20 and 21 on the TM1. Continue on by checking one entire side of the wheel before making any tension adjustments. Write down your results or input them into the wheel tension app at parktool.com/WTA. When we check the left side of this rear wheel, we notice that these readings are lower than the right side. This is due to the fact that the spokes come out of the hub at different angles. The angle that a spoke leaves the hub is often referred to as the bracing angle. When the spoke has more angle, that means that it has more mechanical advantage and will need less tension to counter the opposing side if the opposing side has less of a bracing angle. This is seen on rear wheels and front wheels with a rotor. Your tension goal applies to the side with more tension. The opposing side will simply have lower tension when your dish or centering is correct. Armed with the knowledge of our wheel's current tension, we can start to make changes. When adjusting spoke tension, it can really help to have something to hold your wheel while you work. The Park Tool truing stand is a fantastic option. You'll also need a properly sized spoke wrench to turn the nipple at the end of the spoke. There are many different sizes and even shapes for spoke nipples, which we cover in this article on spoke wrench selection at parktool.com. When adjusting a wheel's tension, our number one goal is consistent spoke tension, or what we call good relative tension. On this wheel, we measured and they were a little bit inconsistent from spoke to spoke, but overall they were a little on the low side. To correct this wheel, we want to raise its overall tension. Since this is a rear wheel with different bracing angles on each side of the hub, increasing tension may change the dish slightly. With that in mind, let's give the spokes on the drive side 1/4 turn each, and those on the non-drive side 1/8 of a turn to start. Now that we have gone around the entire wheel, let's check what our work has done. We'll measure with the TM1 and plug our data into the WTA at parktool.com. We've increased the right side tension on average by 25 kgf, but we have a bit further to go, so let's repeat the 1/4 turn on the right and 1/8 turn on the left. After these adjustments, we can see our tensions have gotten closer to one another, and our relative tension is very close to our target of 100 kgf. If when measuring your wheel's relative tension, you find that the tensions are too high, you're going to need to bring those tensions back down. The process of reducing tension is very similar to increasing tension. You'll just be turning the spoke nipple the opposite direction. The tension of this wheel is too high by about 30 kgf. Because this is a front wheel with equal bracing angles on the left and the right side, loosen each spoke by 1/4 turn. When spoke tensions are this tight, 1/4 of a turn will lower spoke tension quite a lot. Go around the entire wheel like this, and then recheck your tensions. Using our TM1, we can see that our tensions are already down to 120 kgf. You may notice when taking readings that there's some fluctuations in the spoke tension on one side. If the tension fluctuates widely, your wheel may benefit from tension balancing. Tension balancing is when you increase one spoke's tension or decrease another spoke's tension to get the relative tension to be the same. A well-balanced wheel is going to stay true for longer and increase the life of your spokes. A wheel with spokes that are within plus or minus 20% of the wheel's average spoke tension is generally considered to have acceptable relative tension. You will have outliers, however. When addressing these spokes, think about how tightening or loosening them will affect the trueness and dish of the wheel. Here, I will loosen this spoke and tighten this other to keep the relative tension the same. We call this the zone of influence. The zone of influence, tension balancing, and more is covered in detail in our WTA video. So how do we know when our wheel is properly tensioned? Well, if your wheel has good lateral true, good radial true, is properly dished or centered, and your tension on the high tension side of your wheel is up to manufacturer spec, that's a good place to start thinking about stopping. You can keep on fine-tuning your wheel to finer and finer tolerances, but you don't have to have a perfect wheel to enjoy the ride. So that's the basic process for how to check and adjust your wheel's spoke tension.
It's very useful in diagnosing when a wheel has a problem. It helps you document a wheel that has been pulled correctly tight. It also helps you teach new mechanics the concept of spoke tension. We're going to measure the spoke tension, we're going to document it on the computer, and then we're going to look at the charts and statistics that tell us what's going on with the dynamics of the spoke tension. We will need the TM1 tension meter, a caliper, a spoke wrench, a marker, a computer with internet access, truing stand to hold the wheel, and we're ready to go. Open a web browser and go to parktool.com/WTA for the Wheel Tension app. Here, begin with wheel settings. The material drop-down box has 5 choices. Our material choices are represented here. Steel can either be a stainless steel or a carbon steel. Steel is always at least somewhat magnetic. So if in doubt, use a magnet and see if it holds gently or firmly. Definitely a steel spoke. An aluminum spoke will be larger, more material. It is not magnetic at all. The Spinergy PBO is a proprietary fiber material unique to Spinergy. Titanium spoke has no magnetic properties at all. It'll be much smaller than the aluminums. And the Mavic carbon fiber R2R is a unique proprietary spoke to Mavic. For spoke materials other than steel, select the appropriate spoke type and dimensions from the drop-down menu. The WTA will then display this corresponding conversion table. These conversion tables can also be found on the printed chart that comes with the TM1. The WTA is limited to these options for non-steel spokes. For steel spokes, the WTA can generate conversion tables for any size round or bladed spoke. In the round spoke, we want to measure in the middle of the spoke, not at the very ends. There can be butted spokes that are thicker at the end and thinner in the middle. Here, we want to measure where the TM1 would be deflecting. Enter the diameter, rounded to the closest 1/10 of a millimeter. In the blade shape, we need two measurements: the thickness of the spoke and the width of the blade. Use a caliper to measure the thin section of spoke rounded to the closest 1/10 of a millimeter. Take a measurement of the width and also round it to the closest 1/10 of a millimeter. We can hit Update, and this produces a TM1 conversion table that is unique to the spoke diameters that we have entered. The TM1 conversion table produced by the WTA gives us a range of tension readings. Each has a corresponding spoke tension in kilograms force. For example, a spoke with a reading of 9 has a tension pull of 66 kilograms. This is unique to the 1 millimeter by 2.2 millimeter bladed spoke. On a wheel, it is the rim that determines the spoke tension, not the spoke itself. Recommendations for spoke tension can be found at the instructions page of the WTA. Here, we'll find front and rear kilogram force recommendations for several different brands. Always consult the manufacturer for the most up-to-date information. If you're looking for a rough idea, you would stop here. Check the tension chart on the WTA and see approximately where you want to be on the recommendation you're looking for. On this wheel, we're trying not to exceed 120 kilograms. I look on our chart, readings of 15 are about 117 kilograms, so we're trying not to see much more than 15 on the average. So we'll grab a handful of spokes here. 14, 15. We're between 14 and 15. We'll do 14 and a half. Do not try and be more precise than half digits. Here, 14 and a half again. So I don't think we're beyond the recommendation that we're looking for. Depending on if you're high or low from the target that you've selected, you would change the spoke tension on the entire wheel. The WTA also offers an optional wheel tension balance feature. What this does is it helps us even the tension. On the right side of the wheel, we're going to check and document and measure all the right side spokes and then adjust them so they are relatively close to the same tension. The left side spokes will do the same. This gives us a more complete picture of the spoke tension. It lets us document the work that we've done, and it's also useful in diagnosing wheel issues and problems. To use the wheel tension balance feature, scroll down to wheel tension balancing. Here, select the number of left side spokes and then the number of right side spokes. In our example, we have a 20 spoke wheel, 10 per side. We get then 10 entry fields on the left and 10 entry fields on the right. For easy reference, write on the rim braking surface the numbered spoke. This can be wiped off later with almost any kind of solvent. So here, from the valve as a constant reference, we mark 1, 2, 3, 4, all the way around, only right side spokes. On the other side, we begin at the valve again, but now we're going to the left. 1, 2, 3, 4. This is done so that 1 and 1, left and right side, stay together. 3 and 3, 4 and 4, all the way around the rim. From here, begin at the first spoke. We take a reading and we can enter it on the entry field at the WTA. Use the Tab key to move to the next field. Using the Enter key will refresh the page each time and slow your work. At the end, then hit Enter. The WTA will convert all your readings to a kilogram force and produce a radar chart of the relative tensions. Next, proceed to the right side and again use the Tab key and hit Enter or Update. And we get the left and right side tensions, the kilogram force for each one, and we get a radar chart that's representative of the tension of the wheel. The dots or data points that are closer to the center or lower in tension, it's tighter and tighter further away from the center. As the mouse hovers around, it will give you the spoke number and the tension of that spoke. It is normal to see these as not a perfect circle. Some anomalies are possible. It does not mean it's an unusable wheel. The wheel tension balancing page also contains a variance. This is a plus or minus percentage amount that will help the spreadsheet call out spokes that are outside the limit of the average. On this wheel, we have check marks in every box. They are all within plus or minus 20, which will produce really good wheels. If we pick 10%, we can see here spokes that are outside. We have spoke 3, 5, and 7. Here, we do have a couple as well, spoke 5 and spoke 8. So understand it may take more time and possibly an upcharge if you're a retailer to produce tighter and tighter tolerances. The WTA also gives basic stats for the wheel. Left side and right side will have numbers for average tension, standard deviation, the limits that you have selected in your variance, and also the TM1 readings that are equal to the limits in the variance. Check the average spoke tension against your desired KGF target and adjust the overall wheel tension accordingly. For more on adjusting overall tension, visit Wheel and Rim Service in the Repair Help section of parktool.com. It's common to see the right side on a rear wheel be tighter than the left side. On a disc front wheel, however, the left side tension will be higher due to the spacing from the rotor disc. This 20-hole rear wheel turned out pretty nice. Let's have a look at a different wheel. This wheel is a 32-hole front through-axle mountain bike wheel. We have decent tension all the way across the left side. We have pretty good tension across the right side. We can see our diagram doesn't look perfect, yet we're still within our plus or minus 20%. If we change here to plus or minus 15%, you can see we're actually starting to come out a little bit on the right side. If we continue to plus or minus 10%, more spokes are showing to be out of that tolerance. Let's use plus or minus 10%, which brings out the left side number 8 and number 9 as problem spokes. 8 being on the looser side, 9 on the tight side. Tension balance is a process of sharing the load equally amongst the spokes. So right side spokes will be set to be even tension to other right side spokes. The left side spokes will be set to be fairly even tension between left set spokes. Remember, when we true a wheel, we tend to tighten to correct problems. It's a habit sometimes to always go to one spoke to fix a problem when we could be going to several different options. That tends to create imbalances in tension, even if the wheel is spinning nice and true. This wheel is spinning very nicely, but we saw on number 8 and 9 on the left side, we have an issue. Number 8 being relatively low, number 9 being relatively tight. This spoke is 8 and this spoke is 9. They both share a common zone of influence in the middle. We're going to set our caliper to that middle spoke. 8 is here and 9 is here. We get our caliper very, very close, a very narrow gap even pulling the other caliper out of the way. Here, we're going to tighten the loose spoke, possibly a quarter turn. This gap has closed up. We're now going to loosen until we get the same appearance of that same gap. The reason is this will help keep the true in this area. Lastly, we double check our numbers. 24 here, 24. So we've come to much closer tension on these two spokes. We enter our new data and see where it puts us. We enter our corrections. Readings of 24 for both. We hit enter, and these two no longer a problem. We would proceed to spokes 9 and 10 on the right side and make our corrections there. Below the wheel stats is the print wheel set data. This is an option for you to enter the customer's name, should they have one, the rim, if we know the rim, the type of spoke, if we know it, the hub, if we know it. We could enter any notes that we would like. Then we would hit save. What happens is the WTA creates a new and unique URL. This is something that can be emailed to yourself. You can email it to a customer. But please note, the Park Tool Company cannot get any lost URLs. It's the responsibility of the user to track their data. Another option is save as duplicate. What this does is maintains all the same settings and all the same text. If you're repeating the same type of wheel again and again, you can simply come down and enter new readings. A third option is the print option. And here, of course, you can save as a PDF, and this can be emailed without changes possible. If you do email the URL to someone, do realize they are able to put in different numbers as they choose. The WTA is also useful when diagnosing and documenting wheel problems. Here we have a 32-hole rear wheel. It shows pretty decent tension, except we can see spoke 16 on the right side is quite low, and spoke 1 on the left side is also quite low. Here is our spoke number 1 on the left side. This is spoke 16, but from the right side. Here, we can move the rim back and forth, and we can see the problem. This is called a flat spot. If these two spokes were overly tight, they would pull the rim toward the hub and create this problem. But we've seen and documented that these two spokes are actually quite loose relative to the rest of the wheel. What's occurred is an impact has happened here that has bent the metal. We really can't loosen these spokes anymore to return the rim to its shape. The metal has been bent. There's nothing really going to get it back to where it used to be. The WTA is showing the problem that we've seen on the wheel. This can be used to help explain to our customer or to our friend why they really need to look at a new rim. Here is a different wheel. This is a 32-hole wheel that has had a lateral impact or a sideways impact. And what we notice here is that we have a severe crossing of the right and left side tension lines. It looks fairly normal until you come around to spokes 14 and 13 here. So what's happened is through a sideways or a lateral impact, the rim has been bent. The previous user has attempted to tighten the left side and loosen the right side to get it to straighten up, but there is no way this wheel is going to maintain much of a true. Here, an indication again, the rim material is bent. It'll be very difficult to keep this thing true for very long. By taking the time to measure and document and record on the Wheel Tension app, you can produce better wheels. You'll have a better understanding of the dynamics of spoke tension and be able to diagnose when the wheel just isn't working. So find the WTA at parktool.com/WTA.